The second part of this lesson is looking at reference angles and then being able to find trig functions off of those reference angles. A reference angle is always going to be an angle measure that is between 0 and 90 degrees. I know this gets a little confusing when I look at all three of these pictures, but if I notice where the reference angle is located, the reference angle on this first picture off to the left here, hard color to see, off to the left here, is with the terminal side and the x-axis. For the second picture, when I deal with it in quadrant 2, notice that it is still with the terminal side and the x-axis. That location is where your reference angle is located. Then for quadrant 3, here's your terminal side again with the x-axis. This would be considered the reference angle. And then finally for quadrant 4, your reference angle is with the terminal side and the x-axis. Okay, so keep that in mind. Your reference angle is always with the terminal side and the x-axis. It is never with the y-axis. So let's try just finding a reference angle for now. So in letter A, it wants us to sketch each angle, then find its reference angle. We'll do the one in degrees first, because we understand degrees probably a little bit better. We have 210 degrees. So if I was to pick out where 210 degrees is, 90, 180, 270, and 360, 210 would lie in the third quadrant. So from my initial side all the way around, that would be 210. Remember, your reference angle is based on your terminal side and the x-axis. So the part in yellow here, this is going to be your reference angle. We need to find that. And the easiest way to do that is to take your angle that they gave you. I went all the way to 210, but I need to back it off, so I'm going to subtract. I'm going to take 210 minus 180 in this case, and when I do that, we're going to get 30 degrees. So in this case, your reference angle is 30 degrees. We'll do one more in terms of degrees. We'll go down here to the bottom. We'll do negative 110. Remember, the negative just tells you which direction you're going. Instead of going counterclockwise, we're now going to go clockwise. So now it's like I'm going in this direction. This is now 90. This is 180, 270, and all the way back is again 0 or 360. So negative 110 is going to lie in the third quadrant again. Down here at the bottom, negative 110 is going to go from here and around, negative 110 degrees. As far as your reference angle goes, your reference angle is going to be this angle measure right in here with your terminal side and your x-axis again. If we just think of 110 as a positive angle measure, if I go 110 and I got to get all the way to 180, well, that's 70 degrees more, which would make your reference angle. Radians is a little bit harder for us to do. If you want, you may certainly change radians to degrees, and then you can find your reference angle and then convert your reference angle back to degrees again. That's perfectly fine. I'm going to show you how can we find it just using radians. So if I draw this in here, now what we're doing, if we think of our locations, we've mainly been dealing with 180 degrees is the same thing as pi, and 360 degrees is the same thing as 2 pi. So I'm going to put pi over here, because that's the same thing as 180, and I'm going to put 2 pi over here. If I look at my problem, I'm dealing with 2 pi over 3. So it's like I'm cutting my circle into thirds. Okay, so I'm going to actually change this a little bit. Instead of saying pi, I'm going to make this into a denominator of 3. So pi really is the same thing as 3 pi over 3. The reason that I chose 3 was because the denominator up here was 3. Cutting it into thirds. If I reduce 3 over 3, that's still a value of 1. So I didn't change the value of that angle. I just made it look a little bit different in terms of its denominator and its numerator. I can do the same thing with 2 pi. If I want to make 2 pi as something with a denominator of 3, well, I have to multiply top and bottom by 3. That's now going to get me 6 pi over 3. So instead of 2 pi, I'm going to change this to a 6 pi over 3. Said that's still the same thing as 2 pi. 6 over 3 is still 2, which will give me 2 pi. I'm dealing with a positive angle measure, which means that I'm going to go in the counterclockwise position. If I start at my initial location and go counterclockwise and go all the way over, that's 3 pi over 3. I didn't quite make it to 3 pi over 3. Right? I went basically 1 pi over 3 would be in the first quadrant here. 2 pi over 3 would be in the second quadrant over here. So we're going to say that 2 pi over 3 is right here. My reference angle, again, is based off of the terminal side and the x-axis. If my original angle was 2 pi over 3, and to get all the way down here to the other side of my x-axis is 3 pi over 3, then my reference angle better be adding 1 pi over 3. We'll do one more. I'm going to scroll up to the top. We'll deal with one that's got a negative in it. Draw it in this time. Remember, I'm still dealing with radians on this one. So this position over here is still pi. This is still 2 pi. We're going to adjust it to our denominator. So since I have 4, pi is the same thing as 4 pi over 4. 2 pi is the same thing as 8 pi over 4. Notice I have a negative this time, so instead of going counterclockwise, we're going to go in the clockwise position. Just think of going 5 pi over 4. So it looks like I went all the way over. That's 4 pi over 4, but I need to go a little bit more because I need 5 pi over 4. There's 5 pi over 4. Again, find our reference angle. Our reference angle is with our terminal side and our x-axis. If all the way around is 5 pi over 4, but I didn't quite do that much, looks like I need to back off 1 pi over 4. That makes my reference angle.